one more section to go, which is backups and availability. So, all right, so we talked about this. The maximum tolerable downtime is, of course, getting shorter as people are more and more reliant on their systems. And some people require continuous availability, so no downtime is tolerable. And so then you just have to have redundant servers running all the time. You might want to make hard copy data. This happened to a lot of hospitals when they get hit by ransomware. They wish they had hard copies of everything needed. So full backups is backup of everything. We talked about this. Incremental backups is all data changed since the last backup, and a differential is all data changed since the last full backup. You can rotate your tapes, or your backup hard drives or whatever you're using. So you have systems, often ones I've seen are grandfather, father, son, where you have 7 daily tapes, and then you save every Monday tape for a month, and then you save the first tape for the month forever. So you have a lot of tapes get reused, but you can reconstruct things in the past to some extent. Anyway, electronic vaulting is where you back things up over the internet. Of course, it should be encrypted, but then you can have essentially continuous backup as long as you have enough bandwidth to move it up. You can save database checkpoints periodically, and you can have database shadowing where you have 2 identical databases on different servers. Constantly update all the records going back and forth. And next semester we'll be talking a lot about cryptocurrency. A shadowed database is the normal solution, and the most extreme shadowed database is the blockchain, where you make 1 million copies of your database, which is pretty outrageous and hard to justify that vast expense. But that's why Bitcoin is so extremely inefficient and expensive compared to just a database with some reasonable number of shadow copies. So to have a high availability cluster, you have active systems all working and load balanced, or the active passive, where systems they're available but not being used until the main device goes down. You can have software escrow, where you put the source code for your proprietary software somewhere, so if the company goes out of business, you can recover it. There was a law passed a few years ago that says if a supplier goes bankrupt and the product is no longer available, you are allowed to hack into it and reverse engineer it to maintain it and update it. All right. And so to test your plan, first thing, you read through the plan to find flaws. Then you do a read through to list all the components and make sure you've got it. And then you do a tabletop exercise like the one I mentioned in the news for an asteroid impact, where you get all the people there and they talk about, I'm going to do this, I'll do that. Would software escrow be protected for litigation? I don't know anything special about it. I think it would be protected as much as anything else. I think anything in escrow, I used to work at a financial escrow agency, anything in escrow is held like a bank, and they will only hand it out to anybody with a court order. So I would think it would be like anybody else. If you have any kind of property that you're holding for somebody else, then you only hand it over when you get a court order. So I would think so, as IP or anything else. I mean, whoever, the escrow agency that holds it will have some kind of contract, and that will specify who they will hand it out to. Of course, yeah, if you were to say hack in or break into the escrow agency, then you might be able to get the stuff, yeah. Anyway, so that's a tabletop exercise where your team leaders talk about what their teams are doing and make sure they are ready for their stages. And then you can do walkthrough drill, where you actually carry out the steps of recovery, and parallel processing, where you have simulated business transactions on backup systems. And then you can have real business interruption, where you actually turn off some of your working business systems and make sure that the fault-tolerant systems will take over. This is what Cloudflare does. Matthew Prince likes to talk about it. He'll pull a plug and take down a whole data center and make sure that nothing bad happens. And this is what Netflix does. Netflix has the Chaos Monkey running, which is a software product that deliberately breaks systems at random, all the time during real business, to make sure that everybody is always planning for fault tolerance all the way through. And yep, there's the Chaos Monkey link. Good. Yep. So that's the hard test, business interruption, where you're actually breaking real systems that customers are really using and making sure that your fault-tolerant system can handle it. So you got to practice things in training, like starting your emergency power, making sure you can reach all the people with your backup communication system, and making sure that your employees are aware of what their duties are in the case of a disaster. All right, and then you have to maintain your plan. As time goes on, you make changes on the network, your business environment changes, you make partnerships with other companies, your technology changes, so you have to constantly update this thing. And so here's common mistakes: not enough support, you don't have the right scope, you don't think about your supply chains, you don't keep testing, training, and awareness, so the people don't really know what to do, and you don't keep it up to date. These sort of common mistakes you can make. And there are some frameworks, specified frameworks. The U.S. government system has a NIST framework for it. MCP team, management, BCP. Is there an MCP team somewhere? MCP team. I think that was back here. Let me find that. That picture, way back towards the beginning. There we are. Nope, I guess I don't know. Maybe that should be a BCP team. I'm not sure. Maybe there isn't an MCP team. It's a good question, and I'm not sure. I think it should be a BCP. I think it's probably a typo. That's my best guess at the moment. All right. Yeah, you should have a business continuity team member on the change control. That's right. So that when you consider changes, I don't know really the point of this. The point is you consider whether the changes, if you change something, it could be, but I think the point here is BCP. The point is, if you consider a change, like we're going to expand our business to China, your business continuity team has to be on the board deciding whether to make that change. And they will say, wait, if you made that change, we would have all these extra expenses for business continuity. That's the point of this slide. And I'm glad you reminded me. Anyway, there are special frameworks. If you're in the U.S. government, you got a NIST SP document to follow. If you're in the 27000 ISO, there's an ISO document for that. And there is a British standard and then a superseded international European standard for these. These are the official, compliance frameworks for business continuity. And there's a BCI Institute that has their system for it with these PP1 documents that, just like all the other compliance frameworks, covers these various steps. So you can then meet that standard if that's what your business partners expect you to do. All right. So let's look at E, which is here. Okay. All right. All right, I guess maybe that's everybody. All right, what system has MTD0? Yeah, that's continuous availability. All right. All right, what system has two identical copies of a database? That's database shadows. Okay. All right, what DRP test is the most dangerous? That's it, of course. You turn off something while it is in use. All right, which one is not a common error? Of course, people don't usually test too much. All right. All right, Roman. All right. Okay. Good.